Hello, I'm Claudia Wulz. I come from Austria. I'm a particle physicist currently stationed at CERN, but I'm actually employed by the Austrian Academy of Sciences, and in particular at the Institute of High Energy Physics in Vienna. I enjoy my time at CERN here very much, although currently there are not so many people around during the health crisis that everybody knows about. How did I come to CERN? Well, it's a long story, which started actually very many years ago. I heard that CERN employs students during the summer, and through my university I made an application as a summer student, and in the year 1982 I actually was accepted and I came to CERN. I had the big luck that I was able to work at the most important experiment at CERN at the time, the so-called UA1 experiment, which stands for Underground Area 1. You see, this is not a very creative name, but actually the W and Z particles were discovered there. These are very important particles because they are part of the so-called standard model, and they are actually responsible, for example, for radioactive processes. So they do take part in our lives. It was a very exciting time. And actually, this experience repeated itself when much later in 2012 I also took part in the discovery of the Higgs boson at the Compact Muon Solenoid, or CMS experiment, also at CERN at the Large Hadron Collider. Although when the Higgs particle was discovered at the CMS experiment, a very big milestone was achieved, actually the most interesting part is still going to come. First of all, we have to measure all the properties of this Higgs particle in very much detail to see if it really corresponds to what the standard model predicts. However, we know that out in the cosmos we have many things that we do not yet understand. There is the so-called dark matter, which is actually really dominating the mass in our universe. And it is about 5 times more abundant than the mass currently known in the form of normal particles, of which we are all made of, for example. But we do not know what exactly this dark matter is, and CMS can actually play a role in elucidating this very interesting question. And you see already that there are nice connections between particle physics and astrophysics and cosmology in general. And I think this is what makes it so interesting for me as a physicist. I think when I took up my studies at the Technical University in Vienna, I did not expect ever that there would be such an interesting connection and that I could be part of answering actually questions of our entire universe. So this is really what is fascinating me about physics every day, and I hope to be able to witness in what way our physics books will have to be rewritten in the future. Life at CERN is actually very interesting. At least in the past, we were able to welcome many
visitors, and I took part in outreach activities, and I always like to explain things to people. And then often we also are getting asked what do we do in life other than physics. So, well, I tell them, for example, I like to play the cello, which I started to learn as an adult. And an interesting connection to the physics I'm doing, for example, is that even our planets, they are known to emit sounds. Of course, we cannot hear them directly, but we have all our computing infrastructure that is able to really to make these sounds also audible. And I think there are very nice connections. You know, Einstein was a musician himself. He played the violin. And I think it is also, music also asks for your intellectual capacities to be alert, to be sensitive. And I think it creates also lots of ideas. When I play the cello, I can think at the same time and translate these ideas hopefully one day into something that can be useful for physics or for my work in general.